All right. So we title our notes Exponents. All right. So we've got some vocab to get written down, some things to think about. Man, why is it never catches up? Look at that. That's terrible. There we go. That's better. All right. So that's some vocab to catch up on. So we need to get some review from what we know about exponents. I bet you guys already knew this. Right? Powers are what we call exponents. Powers show repeated multiplication. Okay? That's what a power is. We need to get that written down. Powers show repeated multiplication. 2 to the 5th power is called the power. So 2 to the 5th is called the power. I got the power! Exactly. Okay? So, exponents are made up, powers are made up of 2 components. The base and the exponent. Made up of 2 components, the base and the exponent. We need to make sure to get this written in. The important thing to learn today, the number one thing that you've got to come away with, is that the exponent is glued to whatever it's touching. When we have an exponent, what that means is repeated multiplication. Now this thing we got to get written down, this is the last thing we got to get written down here, okay? Is that we have what's called the exponent form and expanded form. This is called exponent form. You're writing the expression as an exponent. Here you're writing the expression as in expanded form. You're writing it what it means. So expanded form is saying, what does this thing mean? Exponent form means, what does it say? That's really what it means. So number one thing that we learn is that the exponent is superglued, not just glued, not glue sticked, superglued. Superglued to whatever it's touching. It's really important. Okay? So here are our 2 main examples. Okay? So let's write these horizontally. Write one of them on the left-hand side, write one of them on the right-hand side. So that way we can compare them, because we're comparing these 2. Questions, are these 2 saying the same? Are they saying the same thing?
They're playing your song.
Yeah. That's good stuff. So now what we have to look at is, really, what is the exponent superglued to? That's what we're really looking forward to. So on letter A, example A, what's the exponent glued to? It's glued to the, Claire? It's glued to the parentheses. That's a really big difference. The exponent is superglued to the parentheses. So everything inside is being squared. Everything. We would read that as -4 squared. -4 squared. Okay? So then when we have this, -4 squared, what does that mean? That means that what's getting repeated, remember, powers are repeated multiplication. What's being squared is what's being attached from the exponent. So what's being squared?
-4.
-4. 2.
What we got? What's being squared? The parentheses. Why? Because what's the exponent glued to? It's glued to the parentheses. So what's getting repeated? The parentheses. So we're going to repeat -4 in parentheses times -4 in parentheses. And we know that same sign, positive, right, gives us 16. That's different than letter B. What is the exponent glued to here?
-4.
Careful.
-4.
It's not glued to the -4. It's glued to
The
the
4.
4. The negative is not the base in this problem, because the exponent is glued to whatever it's touching. Is it touching this negative?
No.
It is only touching the 4. It is just superglued to the base. You would read this as the opposite of 4 squared. Another way you could say this is 4 squared with a negative sign. That's what I say. 4 squared with a negative sign. So what are we going to repeat here? Bless you. What are we going to repeat? The 4. And then we're going to tack that negative on in front. I usually like to write it in parentheses to make my life a little bit easier. Okay? It makes it more obvious what I'm actually squaring. So what's that going to equal? -16. Notice the difference between this one and this one. I draw a line and through some examples. So those were the two main examples that we're going to reference. Let's draw a line and try some more. Okay? Here we go. We'll go through these fairly quickly because we're going to make some conclusions at the end. So on number 1, what's the exponent glued to?
7.
7, not the negative. So it goes negative 7 times 7, which is negative 49. Notice number 2 is going down. Dylan, you can take these notes with us. Number 2 is going down. I got 1, 2, 3, 4, 5, 6, so that I can compare them. Okay. Number 2, what's getting repeated? The parentheses. And now it's negative 7 times negative 7. Same sign. Positive 49. Oh yeah, it's a good song. It's a good song. So notice the difference between number 1 and number 2. We'll keep that in mind. All right, number 3. What is being repeated? The parentheses. Negative 5 times negative 5 times negative 5. Now, can we do all 3 of those at the same time?
No.
Is this same sign positive? No, it's not going to be, because we can only multiply 2 at a time. So let's multiply the first 2. Negative 5 times negative 5 is?
25.
Negative 2. Positive.
Same sign, positive. And now, so why do you think I sing the song every time? Because I never make a mistake with negatives. The only time I'm ever going to make a mistake is if I'm accidentally writing something. I never make a multiplication step with negatives. Why? Because I sing the song every time. I don't make mistakes with negatives because I sing the song. I know better. If I try to do it without, I'll make mistakes. I will. I will. It's because I have. But if I sing the song, I don't make mistakes. Same sign positive, different sign negative. That's going to be negative 125. But wait a second. I thought with exponents, the exponents it was going to be positive. Keep that in mind. What about the next one? What's getting repeated on the next one?
5.
The 5, not the.
Negative.
Good, so it's going to be 5 times 5 times 5. We already know what 5 times 5 times 5 is, right? We just did it. What is 5 times 5 times 5? 125. Wait a second. Weird.
You add the negative.
How is this and this the same thing?
Because there's.
But this and this are not. What's different about 1 and 2 compared to 3 and 4? Addie? The exponent is different. What's different about it? This one is a 3 and this one is a 2. We'll keep that in mind in just a moment. Let's look at 5 and 6. I'll do 5. What's being repeated?
Parentheses.
Parentheses. Negative 1, negative 1, negative 1, negative 1, negative 1. So we're going to do a couple of same sign positives, right? So the first 2 multiply together. Same sign positive 1. The next 2 multiply together. Positive 1, and then of course we're left with that negative 1 at the end. What's 1 times 1?
1.
Times negative 1? Really? Okay. What's 1 times negative 1? Same sign positive, different sign negative. I started it too low. That equals negative 1. All right, the next one. Parentheses again. Right, do our same signs. Same sign, positive 1. Then again, same sign, positive 1. And then again, same sign, positive 1. So I'll put this over here. So, I asked the question, what do you notice when the exponent is odd?
It's
Yeah, click. I don't want to say, so wait, did you hear what she said? Don't worry about it, leave it alone. Did you hear what she said? With negative numbers, the answer is going to be negative. What about with positive numbers? What about 2 to the 3rd? What about regular 2 to the 3rd? 2 times 2 times 2. It's 8. What about negative 2 to the third? Negative 8, because this pattern holds. With negative numbers, odd exponents will give us a negative answer. What about even exponents with negative numbers? Even exponents with negative numbers. Positive answer. But then why is this negative? We're not squaring a negative number, are we? What are we squaring on number 1? We're squaring positive 7, and then making the answer negative. Just be aware what we're squaring. If you square a positive number or you cube a positive number, the answer is going to be positive. If you square a negative number or an even exponent, the answer is going to be positive. If you have an odd exponent with a negative number, the answer is going to be negative. Okay? Let's draw a line across your paper. We have one more section of exponent notes that we need to take about the 0 exponent. So this is called the 0 exponent, this little section of notes. So 0 exponent would be the title of this little section. We would call this a subtitle. Anybody know what a subtitle is? Martez. Say again. I'm having trouble hearing you, man. Oh, you're talking subtitles on a movie? No, I'm talking about a subtitle in general.
No.
It's a title underneath the main title. So the main title of these notes is exponents. This is a subtitle that's a category under exponents. So we just did negative 1 to the 4th and negative 1 to the 5th. So I want you to see this. Negative 1 to the 4th equals 1. Negative 1 to the 5th equals negative 1, right? What about negative 1 squared? Negative 1 times negative 1. It's a positive 1. So what about negative 1 to the 3rd? I'm trying. Look at it. It's trying. It's trying so hard. I almost have it. I feel like I'm going to get it soon. Nope. 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 Almost. Almost. Ooh, that was funny. Oh, come on. What about down here? Nope. What about up here? Oh, okay. There we go. Best I got. That was nuts. That was like 20 seconds worth. So what's the answer going to be for that one? Negative 1 to the 3rd. Negative 1. All right, so what about negative 1 to the 1st? All right, what about negative 1 to the 6th? 1. So what about negative 1 to the 0? Let's look at the pattern. Positive, negative, positive, negative, positive, negative, positive 1. So the answer to negative 1 to the 0 is 1. Because it follows that pattern, right? Makes sense? Number 2 is really easy. What's 0 to the 4th going to equal?
0.
Yeah, it's 0 times 0 times 0 times 0, which equals 0. So let's get rid of that. So that doesn't really apply to our rule that we're going to do. Okay? The next 2. 7 to the 0 and cat to the 0. Yes, cat to the 0.
I see what you're doing.
I do, yep. So let's look at the pattern again like we did for the 1s. Let's look for the pattern for the 7s. Okay, what's 7 to the 1st power? That was really easy. 7. 7 squared? 7 times 7 is 49. 7 to the 3rd, anybody know that one? It's 343. It's okay, you don't have to know that one. It's 343. So the question is, what is 7 to the 0? Okay, well here's how we can look at this. What does it take to get from 7 to 49? I need to multiply 7 times. How do I get from 49 to 343? So how do I get from this unknown number to 7? So what times 7 gives me 7? 1. And that's going to be true with anything. That's going to be true with any of these problems. Let's look at 2 really fast. So the answer, by the way, is 1. Let's look at 2 really fast. 2 to the first is 2. 2 squared is 4. 2 to the third is 8. 2 to the fourth is 16. How do we get from each of them? Times 2, right? Times 2. Times 2. So 2 to the 0. What times 2 gives me 2? 1. So what's cat to the 0 going to be? Well, I got 3 things. Cat to the 0 was cat, 0, and 1. Which of those 3 possibilities fits the pattern we've established? Yes. So, is -1 to the 0 -1? Is 7 to the 0 7? Is 2 to the 0 is 2? So cat to the 0 is cat? No. -1 to the 0 is 1. 7 to the 0 is 1. 2 to the 0 is 1. Cat to the 0 is 1. It's 1. Follows the pattern, right? So the last idea is, what's the rule then going to be? What's our rule for 0 exponents? Equals 1. Because cat to the 0 equal 1, so wouldn't anything to the 0 power equal 1?